Okay, again, we have a pretty straightforward limit here. But again, once we have a rational function, that means there's a top and a bottom, or a numerator and a denominator with x's, we want to quickly check to see whatever the limit is approaching, can we just sub that number in for x, and does the bottom go to 0? So this should be really easy to see as we look at the bottom here. Every term has an x in it, and x is going to 0, so the bottom has to be going to 0, which means we need to do something, and generally that something is factor. So since we know that we can't have an x on the bottom essentially multiplied to everything, because that would, if you just plug in the 0, it's 0 times everything, which is always going to be 0. We need to get rid of that. So if we look at every term on the top and every term on the bottom, they all contain x's. So that means we should be able to factor an x out to the top of the front of the top and the bottom, cancel that x, and then that problem is gone. Let me show you. So the limit as x goes to 0. Again, there's an x in every single term on the top. Even though they're big terms, x to the 8, x to the 7, they all have x's in them. So I can take one of those x's. This is just a common factor, right? Usually you take the highest x power, or the lowest x power out. And again, this negative 3x here on top, that's the lowest power, so the exponent there is only 1. So I'm going to take an x to the front. Then you go through each term and see what you're left with. When you take x out of x to the 8, you're left with x to the 7. So all of that happened, that went right here. So it was x to the 8, I've taken one x to the front, so I'm left with x to the 7. Minus 7x to the 6 now, because he took 1 away. Minus 6x to the 5, because he took 1 away. Plus 5x to the 4. Plus 3x to the 3. Minus just 3, because again we factored that x to the bottom, so 3x becomes 3. Do the exact same thing on the bottom, because we know the bottom is really where our problem is. We don't really care if the top goes to 0. When we take x out of x to the 8, we get x to the 7, minus x to the 6, plus 4x to the 3, plus, again, this is just 6, because we've taken that x out. So that 6x became 6. Now you can quickly see that that x that's causing the problem that's going to 0 can be canceled with this x on top. Now, again, every step of the limit we say, is there a problem? Is the bottom going to 0? Well, if you look at our new bottom, our new denominator, if you plug in 0, this will go to 0, this will go to 0, this will go to 0, but this will not, because there's no x here. So the bottom's going to 6, not 0, so we're good to go. Once that happens, you can just plug it in. Again, everything on the top is going to be, we're going to get 0 to the 7, minus 7, 0 to the 6. I'm just plugging in 0 for x because I know the bottom's not going to 0. Minus 6, 0 to 5, plus 5, 0 to the 4, plus 3, 0 to the 3, minus 3. All over. Again, we've just canceled these x's. I just showed these ones for demonstration, but I'll write them out. So minus 0 to the 6. That's 0 to the 6. Plus 4 times 0 to the 3. Plus 6 on the bottom. Now this should be super easy to solve. This is going to 0, 0, 0, 0, 0. Negative 3 on top. Over 0, 0, 0, 6 on the bottom. This can be reduced to negative 1 over 2. So again, every single limit at every stage of the limit, once you do algebra or whatever, you're always going to test to see if you're done the algebra and the factoring by saying, can I just plug the value in right now, or does my bottom go to 0? If it does go to 0 still, you have to do something else, factor and cancel. If it doesn't, you plug in the numbers and solve for your answer. And in this case, you get negative 1 over 2.